Broadcasting from the commodity capital of the world, Zurich, Switzerland, this is Insider's Guide to Energy.
This edition to Insider's Guide to Energy is brought to you by Fidectis. Go to www.fidectis.com for more information.
Welcome to Insider's Guide to Energy. I'm your host, Chris Sass, and today we're going to talk wind, and with me is Sarah Barber. Sarah, welcome to the podcast.
Hi, thank you.
Well, it's a pleasure to have you here. I think the logical beginning start is let's tell our audience who you are and what it is you do.
Yeah, so hi everyone, my name is Sarah Barber. I lead the wind energy program at the Eastern Switzerland University of Applied Sciences, which is a small university near to Zurich in Switzerland. I'm also founder and president of the Swiss Wind Energy R&D Network.
All right, so you're doing quite a bit with wind. So a small university in Switzerland and this other network. What's your passion? What's driving you to talk about wind today?
Yeah, so some people ask this question about wind energy in Switzerland because the wind energy market is very small in Switzerland. So they're always quite surprised there's some activities going on in Switzerland. So what we really focus on is using Swiss innovation for the global market. The global wind market is massive, it's growing. It needs more research and innovation in order to reach the installed capacity required to reach net zero by 2030. And that's what really makes me, drives me to do what I'm doing. I really think I can contribute to the energy transition. So that's kind of the reason I'm doing it. And the Swiss Wind Energy R&D Network I founded because I realized that Switzerland is a highly innovative country, and there are many small research groups and organizations and startups who do loads of really interesting things for the wind energy market, but also for other markets. And they don't know the potential of what they can do for the global market. So what I want to do is to bundle all these resources and get everybody together to actually develop real innovations for the global market.
The Swiss innovation that's taking place in wind, how is that? I mean, we're sitting here in Zurich. We have a great institution, ETH, right here. I think Luzern's got another technical institution. Are these things that are taking place mostly around the universities, or is this private sector that you're mostly working with?
Yeah, I mean, it's both. It's really both. So there's many activities at ETH Zurich, also at EPFL in Lausanne, and also then at the universities of applied sciences, like you mentioned, in Luzern, but also in Zurich and my university in Rapperswil. But then there's independent organization, startups and companies who are just coming up because they see the demand and they see it's interesting. So it's kind of a combination of both. But the whole point of the network is to bring these people together, because for the most innovative solutions, it's probably quite a good idea to combine university research with market insights or with real things that are going on in the market.
And then what kind of innovation would we be finding here? So I'm in energy here in Switzerland. And when we first talked, I was one of those people that said, it seems like a challenging place to be in wind, since it's a country that doesn't really like having wind because of it. We're a tourist-based economy for a lot of our economy. And so there's been a lot of pushback. But is it software development? Is there engineering developments? What kind of developments have you seen so far? Or maybe give us an example or two of something taking place that's interesting in Switzerland.
Yeah, I mean, there's where to start. There's lots of things that are really interesting. So the focus of my group is digitalization. And with digitalization, I mean using data to provide value, to provide new business ideas and opportunities. So digitalization is one of the things which is also really, really big in Switzerland. That could be data analytics, it could be data storage solutions, it could be data platforms, smart measurement technology. There's some examples of all of those things in Switzerland. So startups, small companies, research. But then there's all the things like structural health monitoring, decision support systems, so how to help maintenance engineers actually make decisions. Then you get the whole topic of composite materials. So Switzerland's quite big on composite materials, and that's very important for example, for rotor blades of wind turbines. Then you've got the entire area of electronics, or let's say power electronics, so led by companies like ABB or Hitachi Energy, as they're called now. They develop massive components for wind turbines. There are companies who develop airborne wind energy. I don't know whether you've heard of that. Do you know what that is? Shall I?
So explain. I'm not sure what you're talking about on airborne.
So airborne wind energy is this concept of these flying wind turbines. So wind energy is great. One of the difficulties with standard 3-bladed horizontal axis wind turbines is that they're quite expensive. And so the idea of airborne is take away the material, go much higher where you have a much higher wind speed, and therefore reduce the cost of energy by flying up like an aeroplane. So the basic concept is that the aeroplane is attached to a rope or tether, and that is attached to a drum on the floor, and the plane flies. It gets controlled, so it flies outwards using the wind. The rope gets longer, and it wraps. It winds around this ground station, and that actually produces electricity just through the rotation. And then when it gets to the top, it gets pulled back in with a low amount of drag. So the energy required to pull it back in is much lower than the energy generated from coming out. And it keeps repeating like that.
So is there a commercial test of that yet? Has that been done at scale yet?
Yeah, there's many companies in the world who are trying to develop different prototypes. And the reason I mentioned it is because there's at least two Swiss startups involved, and they are both working on prototypes. Nobody's actually proven the technology at scale yet, but many people are on the way. It has also, by the way, has many challenges associated with it. So just think about air traffic control, or just controlling it so that it flies in the right place and doesn't crash. It's quite a high challenge. So I'm not really saying that this is the technology for the future. It's one of the interesting possibilities, and it's just one of the things that Switzerland is involved in.
And it makes me think of the high-speed sailing boats. There's a sailboat out of Switzerland that breaks world speed records, and they basically have a kite as opposed to a sail that drives the boat.
Yeah. The other thing connected to sailing, by the way, an example that I could give of a Swiss technology, we have a project together with ETH where we're developing pressure, like smart pressure measurement systems using MEMS sensors for rotor blades. And actually this idea was used originally on sailing boats as well, because it's kind of a similar thing. You've got something moving, you've got quite a harsh environment, you haven't got much space for lots of data acquisition equipment. And so that's just another example.
All right, so you've got some interesting research going on. So you've started this group, and I know that when you and I were on a panel in the past, you also talked about student engagement and getting students engaged. So that seemed to be, you're at a university, so I think you're interested in helping students, but I've heard the passion come through and I've heard you speak before. So how are you tying students into these initiatives?
Yeah, I mean, that is something that's really important. And I think the project that I might have talked about before is called We Do Wind. And so the idea of the We Do Wind project, it's not just to get students, but it's just to get anybody. So regardless of people's background, what country they're coming from, or where they work, to get them involved in solving the biggest challenges of wind energy. So the idea is that it's just a way of it's a way to allow companies to get problems solved. So imagine, I'll give an example of a project that we did. So we were working together with EDP, who's a large Portuguese wind farm developer and operator, and they had a challenge, which was to develop a better fault detection algorithm. And we helped them post this challenge on a platform, and they provided some data to allow people to solve the challenge. And what we did is, in the We Do Win project, we got the whole community together. So we got like 80 people from 28 different countries, including students from Brazil and China and Lebanon, quite a few different countries. And we got them together in different workshops to actually share this data and solve the problem together. And so we ended up developing like 8 different solutions to the problem that EDP had. And this really showed that, bringing people together and getting them to work together actually it brings new solutions. And so the idea is then to expand this so that students from all over the world can actually get access to companies like EDP and get access to real data, to real problems. And I do think this is going to have a large impact on the market, because I've heard from, I work quite a lot with Brazil, so I've heard quite a lot from Brazilian students. They don't know how to even start. They don't know where to, what subject to even study in order to get up to speed on wind energy. They don't know who to talk to. They don't know what the real problems are. So providing challenges like this is a really good way of getting them involved.
And what specifically was the challenge that they were trying to solve?
Yeah, so this one was called the EDP Fault Detection Challenge. So they were developing new algorithms for detecting faults using 10-minute average operating data from the wind turbines.
All right, so this goes back to our conversation we had in a previous conversation about data and having access to data, right? And so this is just a use case where there was some data, and the value of having groupthink on the data is kind of what you're saying.
Exactly, yeah. So the driver of that project was actually this whole digitalization topic. I work quite a lot on digitalization, and I've talked to many people internationally about the challenges of digitalization. And one of the large challenges is this kind of siloed thinking. I mean, it's probably also quite common in other sectors. I'm not quite sure, but in wind energy, it's one of the big talking points that many companies, they're kind of scared to share, and they're very, very siloed in their thinking. And so what we wanted to do is to try to provide a way to incentivize people to maybe share a little bit more, or talk to each other, or not quite be so scared of sharing their data. But instead of, they don't have to share all their data, they can just share a selected amount, and they actually benefit from doing that. And that was actually the main driver. And the idea of this EDP challenge was just to show that this group think, as you say, actually provides a benefit. And now we're doing more projects. So we're getting more data, we're getting more companies, we're getting more people involved, and we're gradually building that up.
So I guess when someone's going, you mentioned students, so we'll finish a little bit more on students. And you mentioned Brazil, where you've talked to a number of students and that they don't really know how to get there. But you also talked about like material sciences, I think, data science. I mean, there's a bunch of different technologies there. So in your university role, do people take, let's say, a data science degree with a minor in energy? Or like if I wanted to go into wind, right, and I don't want to be an installer, if I actually want to go in and do that, I'm probably not studying wind, or maybe I'm studying meteorology, something. But I think I'm probably having a science background and then applying it towards the problem statement. Is that a safe how people get into wind these days?
It's a really good question, and it's really difficult to answer that question. So one of the exciting things and challenging things about wind energy is the interdisciplinarity, right? So you have all these different disciplines, and it really is interdisciplinary. So you don't just have engineering, different types of engineering sciences like data sciences or civil engineering or mechanical engineering, but you also have loads of social sciences and humanities as well. So, even like the people who are living near the wind turbine, why are they scared of wind turbine infrasound, even though it's been proven that it's not actually a problem? It's something about behavioral science, right? And so you get all these behavioral science type questions. You get, as you said, meteorology, physics. I mean, it's basically physics. Many different aspects, even biology. If you're looking at offshore wind turbines and the animals that are growing on the structures, and the question is, how do you teach people about that? So you teach them the basics of engineering or physics or biology, and then they, as you said, they then learn with some use cases, with some real examples, or you do it the other way around. You teach them everything they need to know for wind energy. The current approach is definitely the first one. But there is an argument to say that teaching maybe needs to be thought of in a different way, that there maybe are new courses for, maybe not just for wind energy, but for renewable energy or climate change action or something, which actually includes all these different disciplines. Because the difficulty is when you just teach individual disciplines separately, is that it's very difficult for people then to switch between them, or even to think like a, it's very difficult for engineers to think like a social scientist if they haven't been taught to do that from the beginning, you know? So there's an argument to say that teaching maybe needs to be developed more in a more interdisciplinary direction.
But is that happening in Switzerland? So you're in the academic situation here. So Switzerland, I would tend to be more conservative, traditional academic path from my experience of being here in Switzerland. Is that where we're at, or is there innovation taking place in renewables and how folks are getting trained to be in the workforce?
I don't want to answer for the whole of Switzerland because I don't work at ETH, and that, you know, that's one of that's the largest, or one of the largest institutions, isn't it? So I can't really speak for Switzerland, but I mean, my university is quite innovative with different types of digital teaching methods. So I know, for example, the engineers or the environmental engineers in my university, they do learn about communication, and they do learn about interdisciplinary methods. They do have projects on interdisciplinary topics, and it is coming, but I think it could definitely be pushed a little bit more, let's say.
So from the podcast point of view, we've seen the problem because we keep meeting amazing students that are master's students, undergraduate students, doctorate students. And we started a whole future leaders program to help them get internships, rotational graduate programs. And some of those companies you worked at, right? We work closely with. We know those companies well that you had mentioned as examples. But what I've seen today working from where I sit is they go do an internship, they get engaged, or if they're, you know, they go in, or they go through a rotational program, or there's a formal program at these institutions to bring them in. But typically, most of them that I'm talking to are looking for like an engineering degree, you know, whether, you know, or they're looking for, you know, a master's degree if they're going to the business side, or what they tend to be looking for specific degrees. And I think they're indoctrinating the students that have passions for energy into their what they're doing, is my experience from where I sit. Is that consistent from what you're seeing?
Yeah, I guess so. I mean, there's still quite a traditional way of thinking. I mean, even I think like that as well sometimes, you know. I think I shouldn't really be telling lots of people this on a podcast, I guess, but I often think, you know, if you really want to work in wind energy, innovation and technology, you really need to understand the basics of engineering, and you need to be able to do maths, I think. And which kind of goes maybe slightly against this, what I said before about you need more of an interdisciplinary training in order to be able to think about the way other people, you know, other different types of scientists or other different people think. So I don't actually know really what the answer is. I think it kind of needs both. Yeah, so it's kind of, I see both sides. Is that a good enough answer?
It's an answer, right? I don't think there's a right or a wrong. I think it's just an opinion of where we perceive we're at the moment. So your organization that you're working with, is it a startup right now? Do you have members? Where are you at with your wind organization? And I apologize, I can't remember the full title of the organization right now.
So, I mean, one of the organizations is the university, which is just a university where it's actually quite interesting because I came along to this university wanting to work in wind energy, having had more than 10 years of experience in wind energy. And I was trying to look for something in wind energy in Switzerland, and there wasn't really anything because, as we've said, there's no real market. And I actually got a 2-day-a-week part-time position, and somebody offered me that for a year and said, if you can acquire some projects, you can stay. And now I lead a team of 6 to 8 scientists running many international projects, and I'm kind of hoping there to build up an innovation center in Switzerland. The other organization I talked about was the Swiss Wind Energy R&D Network, which is just a network which I founded, and it's got 190 members. But I mean, some of them are international. Quite a lot of them are international. And also, I have to say, membership's free, so it's not very difficult to become a member. But it's still a decent community that we've built up of people who are interested in Swiss innovation. And then the third thing is this We Do Wind project, which is not actually an organization. It's just a project. And we have on the We Do Wind ecosystem, which is just the place where everybody who's signed up to take part in one of the challenges kind of collects and can exchange information. We have 250 people or something taking part actively in that from at least 30, if not 35 different countries. And yeah, I mean, I'm just trying to build that all up and make sure what we're doing in our research projects is really important for the industry, and also really important just for the world in general.
So how much of the wind that's getting deployed? So we've talked to folks that did like Acker wind offshore. We've talked to some of the bigger names that have been on the podcast. How much of this is controlled by the manufacturer of the turbines and the generation capabilities? Because, there's a few well-established players, and then you've got a number of developers out there that are trying to do the development. Now, I get that there's software and there's data and things you can do on the back end, but how much of this is going to be controlled by the large incumbents that are already in place? Are we at a place there yet? Or is it still a Wild West and there's a lot of opportunity to innovate and bring new technology at scale?
So for the wind turbine technology itself, 3-bladed horizontal axis wind turbines, I don't think they're not going to get replaced by something else. Like the opportunity for an entirely new way of creating electricity from wind is minimal. Like even this airborne wind energy stuff that I was talking about, that's going to be, if anything, it's going to be a niche for locations where large components can't be transported to, or where people think that it looks nicer. It's going to be a niche. So there's not going to be a change in the major technology. There's potential for component improvement. So there's or for, let's say, asset management services improvement to reduce the costs. There's a potential for solutions which help acceptance or improve deployment. You also have very many opportunities in the area of politics and policies, and trying to actually get more wind farms implemented. It's not an area that I know that much about, but I mean, in Switzerland there's hundreds of projects being planned, all being blocked by the way the system works. So there's many opportunities in and around the technology, but the main players and the main technology is not going to be displaced.
All right, so the generation is probably set, and so it goes back to what you said. It's mostly the technology. You talked about sensors, you've talked about software, talked about data. So that's where you think you're going to make the most strides, is where you're focusing your time. Is that safe from what I've heard so far?
Yeah, definitely. Finding some sort of niche where real innovation can help to reduce the costs, improve the efficiency, improve the deployment. That's where there's space. And I think when I say true innovation, what I really see is, like I mentioned, this siloed thinking. Siloed thinking doesn't just stop people from sharing data. It also does kind of slow down innovation, because people are just sharing their ideas with like-minded people. And it's kind of well known that has a certain value, but is limited. So I really think that the opportunity lies in with people saying, okay, I truly do want to work with different disciplines, and I do truly believe in sharing ideas, and yeah, that's why I see the potential, which is why I'm doing what I'm doing.
So what makes what you do different? So as a technologist, right, in an energy tech company, I get there's nuance to wind, but why is what you're doing different than any renewable? Why do I need a wind special focus here in Switzerland as opposed to a renewable focus? Because you're going to still have storage, you're going to have capacity, you're going to have maintenance, you're going to have all these things that I would also have with a PV park, or I'd have with other things as well. So what makes wind unique in your passion, right? Why is wind the thing that keeps you going?
Because wind energy is just the best. No, okay, so wind energy is pretty well proven to have the lowest CO2 emissions over the entire life cycle compared to any other technology. I mean, some of you know that, or maybe you know, it's not that easy to actually estimate the life cycle CO2 emissions, because it depends if you have to take into account the recycling. If you want to take into account the manufacturing, you actually have to go to these factories and measure the CO2 emissions of all these different processes. So it's very difficult and it's very inaccurate, but there's still many studies which sort of show average values with uncertainty bars, which do show that wind energy is the lowest. So which means it's a very important solution for reducing CO2 emissions in the world. But it's not just that. It's also, I really just like the way wind turbines look. I just think they're really elegant and beautiful. And, we have to, if we want to get electricity from our plugs reliably, we have to do it somehow. And I prefer to look at a load of wind turbines than anything else. But one thing that is really important for me to say is that often when I tell people, I really like wind energy, I work in wind energy, I'm passionate about it, doesn't mean that I think the world has got to be supplied by 100% wind energy. And people do kind of assume that. So I do think...
No, but my question wasn't that. My question was, so we're both sitting in Switzerland today, right? And so Switzerland has a limited number of wind production facilities. I can think of one or two that I see when I drive around the country, and that's about it. And so I go, okay, but focusing on the software or some of the elements, and I get that there's unique, the wind, the forecasting is going to be different, and some of the AI stuff that I'm going to need is going to be unique to wind, because if I want to have good forecasting and other things like that, that's probably going to be unique. But if a Swiss organization focused on that, it would seem just as valuable to me. I'm just thinking, right? As it would be to be on all renewables, because some of the things, like you have generation, right? So you got forecasting, but so solar, you got day and night or whatever, or maybe gray times of the year and you get less power or whatever.
Yeah.
You have maintenance prediction and things like that you're going to have through wind parking, and more so for, let's say, a floating or an offshore wind, where it's more cost, where I'm more worried about cost, because every time I send a boat out to go work on it and stuff like that, my costs are extremely high. So maintaining offshore wind, but none of these things jump to me as Switzerland. So I was interested when we first talked, because it's like, yeah, just a very strange place to do it. But then you're saying there's a whole cluster of industry that can benefit from this thing. You have 100+ organizations that are in your organization here, and you've said you've got students that want to be in wind from Switzerland. So I'm just trying to figure out the pieces of, if you're successful. If I go, Sarah, 5 years from now, what's the greatest thing you guys achieved? What is it you're hoping to achieve? Because that's kind of where I'm going.
Yeah. So just a couple of things. What I want to achieve is not necessarily limited to Swiss wind energy. What I want to achieve is I want to get Swiss innovation used to make a difference to the world. But just relating to what you were saying about connections with PV, for example, it's true that a company who is developing AI methods for analysis of wind data also should be doing it for PV, for example. There's actually no reason why they shouldn't. And actually, all the companies in Switzerland who do offer that do also work in PV. And the same with composite materials. You're not going to have a Swiss company just developing materials for rotor blades. You're probably going to have a company developing materials for many other different applications, and one of them is wind energy. And that also maybe is what you're also kind of hinting at, is that does offer many technology transfer possibilities and additional value for Switzerland, because it's actually one of the things that when I'm trying to get funding for the Swiss Wind Energy R&D Network, it's one of the things I try to say as well. Imagine if you get all these companies from the global wind energy market basically telling you their difficulties and sharing with you their difficulties, and then all these Swiss companies are working collaboratively also with international companies on solutions. Surely a reasonable amount of what they're developing and what they're doing can be applied to other things. So it could be applied to, I mean, all the monitoring stuff can be applied to bridges or to cars or drones or anything. And so there ends up being quite a large technology transfer opportunity kind of going in all directions, which is kind of one of the aspects, I guess that's just one of the properties of interdisciplinarity.
All right. And then if I'm one of our audience members who's sitting in North America listening to this, where does the value proposition cross? So, if I'm an energy or renewable projects or doing things, or I'm a student in North America, whatever level of audience member, is there a value to your organization to have? You mentioned you had some international members. Would they be reaching out to be engaged in some of your meetings or conversations?
Yeah, I mean, the let's take the We Do Wind project. It's not supposed to have any borders. Actually, the whole point is to break down borders. So the only difficulty is sometimes the time difference, but we try to have our webinars in the afternoon where people in the US can also take part. But I mean, the whole idea is that people from any other country can and should get involved, because we want a diverse range of people with different backgrounds and different experiences to be part of this group think. If that's relevant, if a US organization is interested in wind energy deployment in Switzerland or not is not actually particularly relevant in that.
Okay, so the We Do Wind project, you said you have a number of projects going on. So it's a project. It's not an entity as such. And you take data and solve problems. You gave one use case. So what would be a use case? What would some American company or Canadian or even off the Scotland or somewhere else, right? Somewhere where there's wind energy. What would they be looking to do? So they'd bring data to your project, and then you would do some sort of work on the data to give them some sort of results, or how does that work?
Yeah, I mean, it can be anything, and it can be country specific, but it doesn't have to be. And so it could be something along the lines of improving fault detection, like we've done before, but it could just also be performance analysis. So I've just recently submitted a paper which is trying to summarize the different performance analysis techniques that are currently available in the literature. And this is literally wind farm owner operators just looking at their everyday data and trying to assess how well is my wind turbine performing? Do I need to make any changes to improve it? Are there any problems? The methods which exist are they're not really summarized or benchmarked or compared anywhere. So one of the things that we could do on We Do Wind, which we're also planning to do, is to offer some sort of comparison possibility where we take some data and we then invite people to test their different methods, and then we do a ranking or comparison where people can submit and then keep improving their methods. And I think a company looking to enhance the way they do performance analysis might find that interesting and useful.
How from a wind farm development, how accurate are the initial estimates of energy produced to what they build? How close does that tend to be? Do you have exposure to that kind of information?
Yeah, I mean, this question is a very funny question because nobody really knows, and this is one of the most interesting topics in wind energy, in my opinion. So you have this difficulty that when you're planning a wind farm, you do a wind resource assessment and you come up with an estimation for how much energy it's going to produce, right? And then as a company who's developing a project, you usually have to get 3 independent assessments, and then you have to take an average or somehow combine the 3, and then you have to produce this bankable wind resource assessment if you want to get investors. And this is standardized, the way you're supposed to do this, but the standard leaves room for many, many different methods and also much improvement. But anyway, so you have this number, and then you build a wind farm, you probably sell it to someone else, it might get sold again at some point along the lines, and then somebody operates the wind farm, and they're getting a certain amount of energy per month, per year, whatever. And actually nobody cares about this comparison, or people care but they don't have the data because it's confidential. And it's a massive gap. So somebody from the National Renewable Energy Laboratories in the US quite recently produced a really exciting study, which I can only recommend reading, actually collecting data from quite a few, I'm not quite sure how many, but quite a few wind farm owner operators in the US. And actually, for the first time, doing a proper, thorough comparison, obviously anonymous and everything, of before and after. And they discovered some biases. But there's a large gap because this is like one study that's been done. And it's not a thing that the industry really knows the answer to. So this would be another thing that We Do Win might be able to solve if companies would share their data, which they probably won't, would be to do some sort of benchmarking process on the wind resource assessment.
Got it. Well, cool. Well, I think we're bumping up against time here. So it's been enlightening. It's been fun to see a little bit of what's going on. It's interesting, like I said, to talk to you because we've already talked before in some other wind in conversations. And I knew that it would be interesting to hear what's happening here and some of the innovation that you're seeing. It seems like the We Do Win project is something that transcends borders right out the gate. So that's a pretty easy one, but it also sounds like your other organizations other than the university where you may get students from anywhere also transcends borders. I want to thank you so much for being on the podcast today. It's been a pleasure to have you as our guest. Thank you so much.
Thank you too.
And for our audience, you've just enjoyed another episode of Insider's Guide to Energy. If you enjoyed this content, you want to find out more, don't forget to subscribe, follow us on LinkedIn, follow us on YouTube, follow us wherever you get your podcasts. And don't forget to add comments because we will answer your comments as well. We look forward to speaking to you again next week. Bye now.